Area of major sectors and major segments. Welcome, everyone. Before we dive into today's new topic, let's take a moment to reflect on what we have already covered. In our previous lessons, we focused our attention on the minor parts of a circle, specifically those smaller regions that are created when we use radii or chords to divide the circle. However, it is important to realize that geometry is rarely just about the smaller pieces. Every time a circle is divided into two distinct parts, the larger, more expansive part is referred to as the major part. In this tutorial, we are going to expand our toolkit. I will be guiding you through the specific methods used to calculate the area of these larger regions, specifically focusing on how to find the area of major sectors and major segments. Let's get started. Understanding the concept of major regions. Now that we've introduced the topic, let's dive deeper into what we actually mean when we use the word major. Think about a circle as a complete, whole figure, representing a full 360 degrees. When we previously studied minor sectors or minor segments, we were essentially looking at just a small slice or a small cap of that circle. The major region is simply everything else that is left over, the larger part of the circle that remains after you've removed that small slice. Because of this, we don't actually need a brand new, complex formula to find these areas. Instead, we use a very fundamental principle. To find the area of any major region, you simply take the total area of the entire circle and subtract the area of the minor region. To do this, you'll always need to remember your baseline formula for the total area of a circle, which is pi r squared. Once we have the total area and the minor area, the subtraction is straightforward. In the next slide, I will show you exactly how to apply this logic specifically to major sectors. Area of a major sector. By definition, a major sector is the region bounded by two radii and the larger, or major, arc. Think of it as the much larger piece of the pizza left over after you've taken one small slice out. To find its area, you actually have two primary methods at your disposal. First, let's look at method A, which is the subtraction method. This is often the most intuitive way to think about it. If you have already calculated the area of the minor sector, that smaller slice we discussed in the previous slide, you can simply subtract that value from the total area of the circle. In mathematical terms, the area of the major sector equals pi r squared minus the area of the minor sector. If you prefer not to do two separate subtractions, you can use method B, which is the direct formula method. As we know, a full circle is 360 degrees. If the central angle of your minor sector is represented by the Greek letter theta, then the central angle of the remaining major sector must be 360 degrees minus theta. You can plug this larger angle directly into your standard sector formula. So, the area of the major sector equals 360 degrees minus theta, all over 360 degrees, multiplied by pi r squared. To make sure you don't get lost in the middle of a problem, I recommend following this consistent step-by-step calculation process. Step 1. Start by identifying your known values, specifically the radius, r, and the central angle, theta, of the minor sector. Step 2. Calculate the total area of the entire circle using the formula pi r squared. Step 3. Calculate the area of that smaller minor sector using theta over 360 degrees multiplied by pi r squared. And finally, step 4. Subtract that minor sector area from the total area you found in step 2. This will leave you with the area of the major sector. Now that we understand the general principle that a major region is simply the larger leftover part of a circle, let's get specific about how to handle a major sector. This systematic approach will be very helpful when we move on to the next slide, where we will apply similar logic to the more complex case of major segments. Area of a major segment. First, let's define what we are looking at. A major segment is the region bounded by a chord and the major arc. If you think back to our previous lessons on segments, you'll remember that a chord cuts the circle into two parts. The larger part is our major segment. Now, here is an important distinction to keep in mind. Unlike the sectors we just discussed, there is no direct angle formula specifically for segments. While we could use a direct angle for a sector, for a segment, we must rely on the subtraction method. The logic behind this is quite straightforward. Think of the entire circle as being composed of just two pieces, the minor segment and the major segment. Because they make up the whole, we can say that the area of the major segment is equal to the total area of the circle minus the area of the minor segment. To make sure you get this right every time, I want you to follow this three-step calculation process. Step 1. Find the total area of the circle using the formula pi r squared. Step 2. Calculate the area of the minor segment. Now, you'll need to recall the formula we learned previously, which is the area of the minor sector minus the area of triangle OAB, and finally, Step 3. Subtract that minor segment area you just calculated from the total area of the circle. Now that we have mastered how to find the area of a major sector, let's move on to something slightly more complex, the area of a major segment. It sounds like a few steps, but once you follow this sequence, you'll find it's very manageable. Let's look at a real-world example in the next slide to see this logic in action. Real-world example. Now that we have covered the theory and the formulas for both sectors and segments, let's put everything we've learned into a real-world example. Imagine you are a landscape designer. You have a circular garden with a radius of 14 meters. Within this garden, a small portion is reserved for a flower bed, which is shaped like a sector with a central angle of 60 degrees. The remaining part of the garden is covered in grass. Our task today is to find the area of this grassy region, which, as we discussed in the previous slides, represents the major sector. Let's walk through the solution step by step. First, we need to identify our given values. We have a radius, r, of 14 meters, and the central angle, theta, of the flower bed is 60 degrees. To make our manual calculations a bit smoother, we will use the fraction 22/7 for pi. Step 2, we need to find the total area of the entire garden. To do this, we use our fundamental formula for the area of a circle, which is pi times r squared. Plugging in our values, we get 22/7 multiplied by 14 multiplied by 14. If we simplify this by dividing 14 by 7, we are left with 22 multiplied by 2 multiplied by 14, which gives us a total area of 616 square meters. Step 3, now let's calculate the area of the minor sector, which is our flower bed. We use the sector area formula, theta over 360 degrees multiplied by pi r squared. Since we already know the total area is 616, we just need to multiply 60 over 360 by 616. Since 60 over 360 simplifies to 1/6, we calculate 1 divided by 6 of 616, which is approximately 102.67 square meters. Finally, step 4. To find the area of the grassy region, we apply the subtraction method we learned earlier. We take the total area of the garden and subtract the area of the minor sector. So, 616 minus 102.67 leaves us with a final area of 513.33 square meters for the grass. As we move to the next slide, keep this process in mind, as I will highlight some common pitfalls where students often lose marks during these types of calculations. Common mistakes to avoid. First, a very common mistake is confusing a sector with a segment. When you are working through a problem, always look closely at the shape. Remember, a sector is like a slice of pizza. It always includes the center of the circle. A segment, on the other hand, is just the cap or the part cut off by a chord, which does not include the center. Using the sector formula when you should be finding a segment area is a mistake I see very often. Second, be careful with your angles. As we discussed in the previous slides, when you are calculating a major sector directly, you cannot simply use the original angle theta. You must use 360 degrees minus theta. If you forget to subtract the minor angle from 360, you will end up calculating the minor region instead of the major one. Third, pay close attention to your calculation order especially with major segments. As we saw in our step-by-step examples, finding a major segment is a multi-step process. You must first find the area of the minor segment completely, which involves finding the area of the minor sector and subtracting the area of the triangle, before you attempt to subtract that result from the total area of the circle. Don't rush this part. Finally, never forget your units. Since we are dealing with area, your final answer must always be expressed in square units, such as centimeters squared or meters squared. Now, before we wrap up today's lesson with our final summary, I want to pause and discuss some common pitfalls. Even if you understand the formulas, it is very easy to make small errors that can lead to the wrong answer. Keep these points in mind, and you will find much more success in your upcoming practice problems. Now, let's move to our final slide to review the key takeaways from this entire tutorial. Key takeaways. First, always remember that the total area of a circle, which is pi times the radius squared, serves as your baseline. Every calculation we've done for a major region starts with this total area. Second, regarding the area of a major sector, you have two reliable paths. You can either use the subtraction method, which is the total area of the circle minus the area of the minor sector, or you can use the direct formula. For the direct method, you use the reflex angle, which is 360 degrees minus theta, all over 360 degrees, multiplied by pi times the radius squared. Third, for the area of a major segment, remember that there is no direct angle formula. You must always calculate it by taking the total area of the circle and subtracting the area of the minor segment. Finally, keep this fundamental relationship in mind. The area of the minor region plus the area of the major region will always equal the total area of the circle. If you can master this relationship, you can solve any problem involving these divided parts of a circle. To wrap up our lesson today, let's review the key takeaways to ensure you have a solid grasp of these concepts before you move on to your practice exercises. Great job today, and I will see you in the next session.